All right, thanks, John. Good morning, good afternoon, or good evening, everybody. First of all, I'd like to thank the organizers here for having me in this webinar series. I'm very happy to talk here a little bit about this project, Xray-Simlab, that I started a few years ago. So before going further, I just want here to share this slide that I've taken from another presentation by Matthias Buissonnier. It's about Jupyter. And I think that this sentence summarizes well the motivation behind the creation of IPython and Jupyter back in the days. I guess, like most of you, I've been using quite a lot Jupyter notebooks for analyzing data and visualizing data and sharing that to other people. But I just like to add a few more items here, just next to data collection, which is like model run, performing numerical experiments. This is the kind of things that I've been doing quite a lot too. And I've been frustrated not being able to fully leverage this Jupyter environment, this interactive computing environment, to do that, and also to share it with other people. So that's here really the motivation behind Xarray-Simlab. And Xarray-Simlab, it's a Python framework for building and running models. And it's focused on these three aspects: interactive, exploratory, and scalable. So I think it fits well in with other tools of the Pangeo ecosystem, which is around the same goals. But here it's more about modeling rather than data. So it's tightly integrated with libraries that you might know well, Xray, Task, Xar, and other libraries of this ecosystem. It's also a domain agnostic framework. Initially, I applied this to landscape evolution modeling. I'm maintaining a bunch of tools under the name of Fastscape here, but I really wanted to make it domain agnostic here, the framework, from the start. To my knowledge, there is it's currently used for some other applications in other domains like hydrology or ecosystem modeling, for example. This project is 4 years old. It has been through a few cycles of a few design iterations, but I think that now it reached a certain level of maturity. But still, it's in active development. There has been recently a very nice contribution I'm very excited about by other people than me. So hopefully, I hope that it will continue in the future. So I started working on this. I was heavily inspired by two things: domain-specific modeling frameworks in Python, like LandLab for landscape evolution modeling. Also other climate modeling frameworks like ClimLab or Climt. And at the same time, there was all these workflow and task management libraries growing up, like obviously Dask, but there's also Airflow, Luigi, nowadays there's Prefect, and all based on this idea of organizing tasks as graphs. And the idea then was, why not reusing the same approach for building flexible numerical models? And that's exactly how works Xray-Simlab. So a model in Xray-Simlab, it's a collection of small Python classes that we call processes. And this is like data class. Actually, it reused the apps library, so it's not exactly the same thing, but it's pretty similar. And then all those processes within model may depend on each other, depending on what is implemented and declared in each process. So that with Xray-Simlab, we can recreate from those dependencies a graph of different processes. So what is specific also to XarraySimlab, as the name says, is that is the interface. So we use Xray dataset as the native structure for input and outputs. We start with input dataset, and then we run some model using a model object, and then what we get is another dataset at the end with all outputs. It's very handy, for example, if we want to integrate the model run into a pipeline with other pre-processing task and post-processing task, or even visualization. And here we can leverage Xray, all the features in Xray, and also all the libraries that are built on top of Xray. What we can do also is running a batch of simulations, one to many models. And here we take advantage of Xray again, the fact that it wraps the multi-dimensional arrays. So we start from a single data set, run potentially many simulations, thanks to Dask and Xar, and then open the Xar back to a single, maybe big Xray data set with all the model runs. All right, so I'm not going to go much further into details on how XarraySimlab works. Rather, I just like to show you here briefly a showcase on how we can use XarraySimlab in Notebook. So let's start importing XarraySimlab. And then here, I also import an existing model, which is implemented in the Fastscape library. So it's a landscape evolution model. And well, let's see what's in this object. So the representation here shows all the processes that we have in the model. There is process for grid setting, for boundary conditions. There is some tectonics processes, erosion processes, so all driving the evolution of the surface topography. And some of the processes here have some inputs. So what we can do also is to access each of these processes, like attribute-like access, like here for the grid process. And what it shows here, it's all the variables implemented or declared in this process that can be input variables or output variables. So value here, which is computed within the process. So let's look at another example here. This is erosion process with other variables. And here, there's another kind of variable, like the shape, which is actually a reference to a variable that is declared in another process, like the grid here. What we can do also is to have a look at the doc strings. In XarraySimlab, there is some automatically generated doc strings showing all the metadata for all these variables in the process. So we can have a look using this way too. What we can do also is to visualize the model as a graph. So this is the graph of all the processes in this model. There is some other options here to show the input variables, for example. But this is all the ways that we can use to inspect models, XarraySimlab model. Very interactive. So what are we going to do now? Just before running models, I just want here in this notebook to slightly change the model setup and tweak it a little bit. So I'm going to import a single process from Fastscape, again here, and take the original sediment model and replace some processes here, like the initial condition here, initial topography, by this escarpment process. And I want also to drop in a couple of processes here that I don't need for the numerical experiment that I'd like to do in this notebook. So what it does here, this code creates a new model object. It works exactly as the other object, like the sediment model. except that it just had some different processes in there and also different inputs. All right, so we have a model that we can use here. Let's create simulation setup then, still in a notebook. So there's an Xray-Simlab, very handy IPython magic command. It's create setup. So what we need to do is to provide the model objects and some options, and it's gonna create a cell code here with all the input variables. And then what we just need to do is to fill this with some input values. This is something that I did to be a little bit faster here. I already did this in this cell, sets a few values here. What I did too is set some clocks. So the clocks here are used for the time step of the model, like time, but also we can specify other clocks for saving model output snapshots. Like for example, here out, it may be used for saving snapshots every 2 time steps. And this is what I do here. So I specify some model variables that I want to save on this clock. So what does this? It yields a Xray dataset that contains everything that we need to run a simulation for that model. So we have the inputs here, data variables, and we have coordinates, time coordinates. What's nice too is that we can, in an Xray dataset, just pass along metadata from the model into the dataset object, like here attributes, which show the description of each variable here. All right, so then next we can run a model. We can with this, so just taking the inputs data set, run the model here, and then what we will get when it's finished is DS out. This is another data set, very similar, but with some additional coordinates and data variables with all the model outputs. So in the output data set, we have the whole simulation, so the setup and the results into a tidy format that is Xray dataset. And then what we can do about do some visualization using Xray. Here, this is the plotting tools built in Xray to show the evolution of the simulation. So in this case, this is the retreat of an escarpment. So this is the topography here. And you see that the escarpment is eroded from left to right and is retreating further to the right of the domain. Maybe it's helpful to use hvplot here to have a better sense of the model dynamics. So hopefully you can see here how evolved the model. Here, how evolved the topography. We could use other things in Jupyter, like Jupyter widgets. Here, this is based on IPyGani, and it's a 3D visualization of the simulation, showing here the retreat of the escarpment, the erosion, and also here how evolved the river network system during the simulation. So hopefully you can see that very quickly we can create a new simulation, run the model, and then visualize the outputs. What we can do also is doing some sensitivity analysis. So here, what I do is taking the data sets, the input data sets created before, just updating one parameter here. And instead of providing one value, I'm going to provide a bunch of values and a dimension label batch that is then passed to the run function to run a batch of model runs. It's run with Dask. It's stored in a Xarray store, and then it's opened back into a Xray dataset that is again very similar to what we had before. But here with an additional dimension here, which is the parameter here that we vary here. So what we can do, just reusing, for example, HV plots and explore the time dimension, but then now we can easily explore the parameter dimension and see how the value affects the simulation outputs here. So it's still very interactive. Finally, I just want to show a final example here, how to customize models easily with Xray-Simlab. You can write your own process class. Like we do here, we want to change the erosion efficiency suddenly at a given time. So what we need to do is to create a small class, declare a variable here, which is the time when the change occurs. This is reference to other variables that are declared in an erosion process. It's erosion efficiency parameters, and we want in this process change the value here. So this is intent out, and this is what we do here in some methods that implement simulation stages. So let's run this. We have now a process class that we can integrate into the model we use so far. We have a new model object here, starting again a simulation, updating just the variables to set this new parameter created here and run the model, and finally see the outcome of this new simulation. So here, what I show is the erosion rates. So in red, this is erosion, and in green, erosion, and in red, this is the position. And now at the middle of the simulation, you see the escarpment retreat accelerating because of the change in the parameter value that we just implemented here. Right, so that's what I wanted to show you. I hope that it gives you an overview of what we can do. This is an example with landscape evolution modeling, but you can write your models in other domains with the same kind of tools. I'm already running out of time, so I want to have time here to cover all the other features that are implemented in XarraySimlab. There are many other features. You can have a look at the documentation of XarraySimlab and see how you can use that to implement even more flexible models or extensible models, and also have fine control on the simulations. So I list here the other features. So XarraySimlab it has already quite a lot of features, but it's not a perfect tool, obviously. There is a lot of room for improvement. I just list some potential improvements. The first one is, I'm very excited about this ongoing work by Juppé, and it's adding an alternative way of defining the process dependencies. Hopefully it's going to enable a workflow that is more familiar to modelers. For example, declaring a variable in one process and then passing this variable on to other process in a given order defined by the user, the modeler. And I think it's more common workflow for modelers. It's not possible currently, but it will be possible in the future. So what we can do also is, well, maybe we can reuse XarraySimlab not only for time-dependent models like I've shown you here, but for for data workflow as data workflow system, because it already has an Xray interface here. we can leverage this maybe. We can also maybe create other interface, command line or graphical based on Jupyter widgets and have real-time models. And well, what I hope the most here is to attract more users and contributors. I don't think the user base is very large right now, but I got so far lots of very helpful feedback from other people, and I really hope it's gonna continue that way. And I'm really eager to see what kind of models people can implement with this framework. All right, so yeah, I think I'm done. I already run out of time. So yeah, thanks for your attention. Feel free to jump in here and give feedback on the repository here at XarraySimlab. And yeah, thank you.
All right.